telescope. And so when I show the enhanced color, it's amazing the detail that you can see in an enhanced color image, but it's really there in the more subtle natural color of Jupiter's atmosphere. I'm going to take you on a tour from the North Pole to the South Pole. It's not from the same pass. We've made 8 close passes now, and I've basically kind of picked out my favorites all along the way. And this is where I'm getting now into our new perspective. So this is what Jupiter looks like to an Earth-based observer. This is what it's looked like to many spacecraft that have gone by. Here on the right is what it looks like to JunoCam. So we have stitched together the images from looking at the North Pole, our longitudinal swath. This particular one went over the Great Red Spot, and then the South Pole. So starting here in the north, I'm going to take you on a tour. So this was from Perijove 7, and this particular image was processed by Brian Swift. And so what are the things we've learned? Actually, it's an outreach camera. We're doing science as well. So one of the first things that became obvious is that Jupiter's latitudinal structure breaks down as you get to the poles. So those belts and zones go away. And as you come into this polar region, everything gets more swirly, and there's cyclones and anticyclones. And in particular, around the North Pole, there are 8 circumpolar cyclones. And this is really different from any other gas giant, because we know what the poles of Saturn look like. We know what Neptune and Uranus look like. None of them look like this. So here's Jupiter being uniquely itself once again. This is a little time-lapse sequence, and so you can see here that these storms really are rotating, and so we were able to map out the direction of rotation, and this is how we know they're cyclones, from the direction of the rotation. We were actually surprised that we were able to detect motion. We were not actually expecting that, I have to say. Okay, this is my Halloween poster, right? One of my personal favorites. And okay, so it's a little hard to see, but these 2 storms are so much alike, and yet they're different colors. Why would that be? I don't know. So this is the southern edge of the northern folded filamentary regions. And so that's at a subspacecraft latitude of about 52 degrees. So I've moved you now away from the North Pole. We're headed south. We're at about 52 degrees latitude. And this is what it looks like. This is what we call the north-north temperate belt. And I'm going to show you a close-up of these clouds here. This is our new view. We are so close to Jupiter that we have higher resolution, more detail in our images than most of the other spacecraft that have been there. But also, because we don't have a big telescope, because we have that wide fisheye lens, we get not only the high resolution, but we also get the context, the surroundings, and the cloud structures. This is the North Temperate Belt. So just a little bit about Gerald's work. He has figured out, basically experimenting with the data, how to flatten out the brightness difference from the terminator, where the shadow is between night and day, and the bright edge, where the sun is shining. And so we call that flattening. He flattens the images. And then other people take his work and do their own. And so, for example, here, Justin has used Gerald's pictures as his starting point and come up with his own beautiful product. We have a couple of amateur astronomers who are really not amateurs. One of them is John Rogers, who is the head of the Jupiter division of the British Astronomical Society. And he will go in and label everything that we see in the images, and then he connects it to the historical record of that the amateur astronomy community has been following storms evolution on Jupiter for decades. And so he goes in, he does all the labeling. I don't have to do anything. I do want to point out this little dark spot here is the shadow of one of Jupiter's moons. And just to take the annotation off, it's a little easier to see what's happening in the, and so this is a set of about 5 images that have been mosaicked together. Here's the south equatorial belt. And so really the best part of the image is here in the center. This is looking out at the horizons, if you think back to that little diagram that I had. And it's very foreshortened. Oh, but let me just point out. So now we're into the southern hemisphere. We're down to a latitude of minus 14 degrees. What's next? The Great Red Spot. And so we've only passed over the Great Red Spot once. That was on our 7th Perijove pass. And so at first the spacecraft was north of the Great Red Spot, so it appears at the bottom of the image. Then the spacecraft was above the Great Red Spot. And then the last two, the spacecraft is now south of the Great Red Spot, so it's at the top of the image as seen from the spacecraft. And this all took place in the space of about 10 minutes that the spacecraft moved that far, that fast. So here's some examples of how what you can do to manipulate the Great Red Spot. Carlos Galeano contributed these. And so starting here, this is our raw data. And with different kinds of color enhancements and contrast enhancements, you can choose what sort of detail you'd like to pull out. And it's all here. It's just harder to see. So he really has done a service in creating all of these different renditions. And here's another one of his that I particularly like, some of the close-up shots. Here's an artist's way of looking at the Great Red Spot. Is it, I don't know, peeling paint? Is it flower petals? I don't know. All I know is I love it. And we have a lot of artistic contributions on our site. Really a lot. They're really wonderful. I'll show a few at the end. How large is the Great Red Spot? Well, it's bigger than the United States. It's actually big enough to eat the Earth. So these are two, again, a couple of amateur contributions. Who doesn't want to use these in your lecture slides, right? Here it is again. This combo of folks, Gerald and Sean and Sander, just do beautiful work. And I just want to point out some of these really high clouds here. What we're working on now is figuring out the structure and how the JunoCam images can contribute to our understanding of the structure of the Great Red Spot. So that's our close-up. And what collection is complete without a cat? I ask you. So we get these wonderful whimsical contributions as well, and I love them all. In fact, I should say,